All right, now that we've talked a lot about the file I/O and sort of file management, input, output, all that kind of stuff, we're going to jump into something called an exception or exception handling. So up till now, when we write our programs, if we make an error, we get the red letters, right? So it runs and it runs and runs. When it hits an interpreter error, it just errors out. We get the red letters. The entire program crashes. So what we're doing at this point is we are not gracefully handling any issues, okay? That's what it's called. We're not gracefully handling errors. So a way to more gracefully handle errors is to use something called exceptions. Okay, so an exception is an error that occurs while a program is running. We've seen a ton of them where we have, say, type errors or format errors or syntax errors. Whatever these errors may be, each of these errors is an exception. So again, that error occurs while the program is running. And whenever we don't handle exceptions, it just causes the program to halt, right? So it hits that point and it's like, I don't know what to do with this, and it just shuts down, okay? So the trace back, we've also seen that a lot. That's that red letters, those red letters that kind of tell us the line and it tells us the issue and it tells us what's going on. That's called the trace back. So it's the error message that gives information regarding line numbers that cause the exception. So it gives the line number, says what the exception is. Generally, it even has something to offer on how to fix it. So it indicates the type of exception and a brief description of that error. Okay, so we've seen these exceptions getting raised often, but generally the sort of default way of handling these exceptions is to just shut the program down because it doesn't want to break anything, doesn't want to corrupt any files, it doesn't want to mess up your file system, so it just shuts it down. So there's an exception, shuts down the program, whatever. Okay. Now, a lot of exceptions can be prevented by careful coding, right? So we want to make sure that we pay strict attention to how we're writing our code and making sure that everything is good. So again, input validation, you can make sure that a user's input is correctly formatted so you don't have any exception issues. So if you're asking for an age, you want to go ahead and check to make sure that's an integer before you let it return, okay? So it usually involves a simple decision construct or some sort of a loop, right? But some can't be avoided by careful coding. Again, converting non-numeric strings to an integer, right? So if I have the name Adam and I'm trying to convert it to an integer, that's going to throw an issue. So we can use exception handling, and actually we can use exception handling in input validation, and I'll show you how to do that. But these exceptions can't be avoided because if I put in a string and it's actually supposed to be a number, it's just going to mess up. That's all there is to it. And again, trying to open for reading a file that doesn't exist, right? It's going to try to open that up and it can't open it because it just doesn't exist. So what we have are these things called exception handlers. Okay, so we throw an exception. Let's say we throw an exception of file not found. So we're trying to open something that doesn't exist. We could create an exception handler, and actually there are already exception handlers. The current exception handlers, the default exception handlers, just shut the program down, essentially. But we can create our own exception handlers to allow us to gracefully manage some of these issues. And these exception handlers is essentially code that responds when exceptions are raised and prevents the program from crashing. Okay, so for instance, we're in an input validation program and we want to make sure that the user is entering an integer. Okay, what we can do is we can use this try except statement. We can go into the try block and we can try to convert their input into an integer. And then we can use an except statement where we can catch that and decide whether or not it did right. So again, if I enter Adam, the int is going to throw an exception, which means I want to jump into the exception block and it's going to say, hey, you need to enter an integer. And then that can actually, make sure that the Boolean isn't changed, right? So while good is false, we loop, 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 loop. If we jump into the try statement and then we try int my input, and that works out, then we can actually set the Boolean to true and jump out of that while statement. And again, I can go ahead and show you what that looks like here in the code. So you can actually use exceptions for logic as well, right? So if someone enters the wrong thing, then you can go ahead and change variables, you can change Booleans, you can raise flags, you can do all kinds of cool things. So again, we use try except statements or try except blocks, okay? So in general, you're going to have try, then you're going to have statements that you're going to try, and if any exception is raised in those statements, then you have accept, and then you can accept exception name. Now, there's a bunch of different exceptions, right? We've already had, type errors, we've had file not found errors, file I/O errors. We even have a base exception error that we can utilize as sort of a catch-all. So we can do a base error exception as a general thing, to start out with, to kind of mess around with it. But what we want to do is we want to try to catch each error and respond specifically to those errors. A good program responds appropriately to the exception that is raised, which means you're actually going to be handling multiple exceptions simultaneously. Okay. So again, this is a try suite, which is the statements that can potentially raise an exception. So inside of the try suite, you have, or the try block, you have, try to convert it to an integer, or try to open the file, or whatever that might be. And then the except, which is the handler, is the statements contained in the except blocks, is what you do if there was an exception. So if the statement in try suite raises an exception, then the exception specified in the, so let's say it raises a file not found error, okay? If the exception is specified in the except clause, then the handler catches it, and then it executes the statements in the except clause. Other exceptions, the program halts with a traceback, okay? Now, if we use a base exception, it'll catch all exceptions. And the way that we want to try to do this is we get more specific to least specific in the way that we handle our exceptions. And we'll see that in handling multiple exceptions, where you have the more specified exceptions at the top of your exception. So you do your try block, and then you have your first except block, which is very specific. Second except block is less specific. And then you get finally down to a base exception to just handle all the general exceptions. Okay. Now, again, if no exception is raised, then the handlers are skipped, right? You don't need to worry about that. So as I mentioned, we do want to be able to handle multiple exceptions. So often coded try suite can throw more than one type of an exception. So you have to write an except clause for each type of exceptions, though. And an except clause that doesn't list a specific exception will handle any exception. Okay. So, and we can just do a basic except, but I always like you to go ahead and do base exception because that's the base class for all exceptions. All right. So again, with each exception, we have these traceback data, right? So at this point, we're not handling exceptions, which means that it's just displaying the traceback data. Well, if we handle the exception, we can actually grab that traceback data and display that back. So, and that's called the default error message. Okay. So an exception object, when it's thrown, it's created in memory, and it actually has the default error message. It has the information, it has the line numbers, it has all that kind of stuff in it. So you can assign that exception object to a variable and then print that variable object, right? So you can do except value error, and this is actually missing spaces, so I'll just put those back in. Expect value error as ERR, right? And then you can pass an exception object into the print function and just go ahead and print that all out. And I'll kind of show you this as well. You obviously, with the try except block, we can do some different additions and stuff that you can do. So you could do a try except statement, and you can have an optional else clause which appears after the except clause. Okay, so it would be try except else, a block of statements executed after the statements in a try suite only if exceptions were raised. Okay, so an exception was raised, the else suite is skipped. Okay, otherwise the else suite is not skipped. So you can try the try block, and if everything goes fine in the try block, then you go to the else statement. Okay. You also have a finally clause, and that again comes after all of the except statements, and it can include, this optional finally clause, where you have finally do statements, and that's a block of statements after the finally clause. It executes whether the exception occurs or not. Okay, so you try this, then you get exceptions, and then you can have an else, and then finally it's just something that is done, right? So you can try to open a file and then use finally to actually close that file, right? So we have the else, we have the finally as well. Okay, so that's sort of generally how we're going to deal with those. And again, I'm going to show you sort of how to handle those in PyCharm. So again, if an exception isn't handled, what we get is a crash, right? So we can actually have a crash, or we can, so there's two ways for an exception to go handled. So no except clause specified in the exception type is there, right? So let's say you specify file not found exception and it's a type error. Okay, well, it's just going to crash, right? Or the exception is raised outside of the try suite. Okay, so let's say you're handling a file not found error, but you try to open the file outside of a try suite. Well, then it's going to not be caught, right? So in both cases, the exception just causes the program to halt and throws the trace back. Okay, so that's sort of how the exceptions work and sort of what they are. Okay, so let's go ahead and jump over here to PyCharm, and we're going to jump these exceptions here for a little bit. So let's go ahead and just practice with a file not found error. Okay, So we know that we can try to open a file that doesn't exist. So I'm just going to call it file IO2, and I'm going to open that for reading. Okay, so now when I run this, you're going to find, because there's no IO2 over here, it's going to go ahead and just throw out this traceback. Okay, so let's just analyze some of these terms here. So we have an exception. Okay, this is the exception, the file not found error. That's the exception that's thrown. This is the traceback right here. Okay, so in the file io.py, in line number 6 is where it started. So it entered here, and then it hit main. It called main. It jumped to main. So in line 6, it called main. And then in line number 2, in main, it says f equals openio2.txt. That's where the error was thrown in this particular line. And it says file not found error, no such file or directory. Okay, so it says there's nothing there. Okay, and then I crashed. So what I can do with this is, let's say I want to read it, and if it doesn't exist, I want to create it. Okay, so what I can do is I can do a try except block. Okay, so I'm going to go ahead and try to open it. If I don't get it opened, I'm going to go ahead and write an except block. Now we're just going to use, and actually no, we're not going to do that. We're going to use the file not found error. Okay, and we're going to go ahead and save that as ERR. Okay, so we can go ahead and print the error that we get, and then we can go ahead and open it in a different way, right? So we can say io2.txt, and we can open that in W, right, in write mode. All right, so that means if it's not available to read, I'm just going to go ahead and create the file. Okay, so what I'm doing is I'm trying to find it, and if I don't find it, I'm going to go ahead and make it. So we're accepting this file not found error, and I'm going to print out the data that's associated with it. Okay, so now what we can see is I went ahead and tried it. I wasn't able to try it. I threw a file not found error, and it went ahead and printed that out right here. No such file or directory, io2.txt. That's what it printed. And then I went ahead and executed this file equals openio2.txt w. Right? And you can see now I have io2.txt over here. Okay, so I'm going to go ahead and delete this again. All right, and here's what I want to mess around with. Let's go ahead and use that finally block, because we know for every open there is a close, right? So we want to do an f.close, right? So essentially what ends up happening is I'm going to try to make f this. If I don't make f this, then I'm going to do this. Now here's one issue that could happen. If there's a different error found, then we have a problem, right? So I need to make sure and handle the most general errors, and I'm going to call that a base exception as ERR. Okay, and then we're going to go ahead and print ERR, and then we're going to go f equals open. We're going to go ahead and open that anyway. Oops, io2.txt in write mode. Okay, so that means that no matter what happens, we're going to have an F, and it's not going to try to close something that doesn't exist. Because right here, it's going to tell us, hey, it may be referenced before it's assigned, right? So I could have it just open something, but there's really no way to handle the error effectively if I do that. But I know, because I'm handling all the general base exceptions here, that I'm going to have an instantiated F, and everything's going to be fine. Okay, so let's go ahead and run this again. Now we should have a file not found error. All right, so we had a file not found error. We printed that out for us. We went ahead and opened it, and then we went ahead and closed it. So now that it exists there, it should open it in read mode, and we won't get an exception. And then it closed it out. Okay, so let's go ahead and just do this again, and I'm going to do some print statements here. Opened in read. Okay, and then here we're going to put opened in write. And then here, random error opened in write. Okay, so now you can see how I can delineate, and I can tell myself as the software developer what happened, right? I can say, oh, here's the thing that happened, right? So here we go. Let's run this again. So it opened it in read because it exists. So let's delete this. I just highlighted and hit delete. Delete anyway, and we went ahead and deleted it. So now it's going to tell us that it opened it in write. Open it in write. There we go. Everything is good. Now, if we had a different error, so let's go ahead and just make an error happen. Int error. So I'm going to try to convert integer. I'm going to try to convert a string to an int. random error opened in write. Okay, you see that? So that means that I actually messed that one up. But here's the thing. If I go ahead and print off error, let's go ahead and do that. We can see what error that raised. All right, so we run this. Invalid literal for int with a base 10. Now, if we didn't have this block right here, so let's go ahead and cut this out, we're going to see it crash again, right? Boom. Unbound local error. Okay, well, and that was because it created an error and then it tried to do this. But there is a value error as well. So now we actually have two issues, right? So the first one that we want to look at is the value error. Okay, so let's go ahead and make an accept block to handle the value error. Accept value error as ERR. Okay, so I went ahead and created that. So now what I can do is I can actually just get rid of this. I can mark these out. And now when I throw this, I'll go ahead and write that anyway, right? So we're going to print that error and everything should be fine. There you go. Okay. All right. So that is what we have. And at this point, if I can actually protect it even further, so I can put another try block in here. I can try to close it. Okay. If there is an error, which we saw that it was an unbound, local error as ERR, what we can do is we can just do a print statement. File does not exist, and we can go ahead and make it anyway. F equals open, and then we're going to open io2.txt. We're going to make it in write mode, and then we're going to do f.close. Okay, so now we have handled all of the potential eventualities in this particular issue. Okay, so right now it's going to raise a value error. It's going to open it in write. Okay. If it doesn't exist at all and we throw some other sort of error, okay, so like let's get a, well, actually let's just mark this one out so that we can force it to go into that other block. Okay, so we're going to get rid of this value error, okay, so we can force it to throw an error that we aren't handling. So in the finally, it's going to try to close it, and then it's going to find an unbound local error, and then we're going to go ahead and close it that way. Okay, so we're going to delete this. All right, delete it anyway. There we go. File does not exist. Okay, so it was a value error, and then it printed that out, tried to open it, tried to close it, and then we did actually have a value error as well that wasn't caught because we got into the finally block and didn't handle that value error. Okay, so there we go. There's an error handling, and if I wanted to make sure that this worked out, then I can see that that logic works, right? Value error is ERR, and I can say F equals open io2.txt and that's not right. And then I can do an f.close, and there we go. Okay, so now even if we run it here, we could say print value error. Now, since it's not handled here, I'm handling it in here just in case, right? Oh, and we're not having to... Oh, it's because I'm raising it here, so I'm not able to handle it here. So I absolutely have to make sure we handle it right here. Okay, so now we have dealt with all the issues that could possibly arise in, believe it or not, 2 lines of code. Okay, so now no matter what happens, we're going to have things work out right. So we have an invalid literal for int base 10 error, and that went and just printed that out, but it opened it anyway. Okay, so here we just have value error. So let's run that. There we go. Is a value error. If I get rid of this, then everything should work fine because it opened it in read. Okay, so there is your try catch block. Sorry, this was a longer video, but I wanted to go ahead and just finish this out on this video. All right, so open up your PyCharm, mess around with this, play with it a little bit, have some fun with it, and that is the end of chapter 6. We'll see you in the next chapter.